What is going on? Honors Geometry. It's your boy, Mr. Bivens here. And hopefully, you are enjoying the pounds and pounds of feet of snow. Currently, it's not snowing where I'm at over here in Maumelle. So I'm kind of annoyed, kind of waiting on the snow to come. For homework today, you got a couple things. First, make sure you make a snowman. Best pictured snowman will probably get a prize. Number two, you need to eat some snow ice cream. And number three, we got to hit some hills hard. Don't get hurt, of course. That would be terrible. But again, I hope y'all are having a good mini break here. We got a quick lesson on rectangles. Hopefully, we all know what a rectangle is. If not, we are going to talk about it today. So without further ado, let's quickly remind ourselves what we talked about 2 days ago on Thursday and what we're looking forward to. So on Tuesday, we talked about parallelograms, which we found out they had pairs of congruent parallel lines. We call them parallelograms for a reason. And we're in our study of what we call quadrilaterals, just four-sided shapes. They're pretty boring, don't have a lot going on for them. But today we're really going to hone in on what are rectangles. And again, as I mentioned in class on Tuesday, in our study of parallelograms, all about what we learned about parallelograms are going to apply to rectangles. And so you have those notes with you from Tuesday. And looking forward, we're going to be studying a whole lot of shapes on Monday along with our quiz. So we got a pretty busy packed day going. But let's just start our day with some nice rectangles. So 6-4 rectangles. Go ahead and get your notes ready. You can pause if you need a moment. All right, sounds good. Thank you for pausing and unpausing. And we're going to begin with rectangles. The definition I'm going to give you is that a rectangle is simply a parallelogram with 4 right angles. And I will also show you this picture. Again, I hope that we know generally what a rectangle looks like. You know, they had those little boxes you'd put shapes into when you were younger to figure out, a circle goes in the circle shape, square shape, rectangle shape. And so now we get to learn even more about them. So that's fun. Rectangle parallelogram with 4 right angles. As we can see, this is rectangle ABCD, and we notate it like this. We notate, and this is very similar to parallelograms, we notate the parallelograms as something like this. That was terrible. I'll do this. Parallelogram, if this were a parallelogram, which it technically is. Rectangle ABCD, it has sets of congruent sides, parallel sides, opposite angles are congruent. You have some other things we noticed, but the main thing here is it has 4 right angles. And speaking of properties of parallelograms, I'm going to first show you guys the 4 that we talked about for parallelograms. As I mentioned, all of those apply, so we know parallelograms have opposite sides, are parallel and congruent, angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. All of those are going to apply for rectangles, so I suggest writing those down. And then hopefully you can use the definition of a rectangle, which we just talked about, to guess what the last property is, aka property number 1. And that's, of course, that all right angles are congruent, okay? Not that they're congruent. All 4 of the angles are right angles themselves. They are also obviously congruent. These are the 5 main properties. Again, all of the ones in yellow are just inherited from parallelograms. This is kind of what makes rectangles their own standout, cool new shape. All 4 right angles are congruent. If you need a moment, pause, write this down, and when you're ready, you can click play again and move on. Good. So let's talk about diagonals. Hopefully we remember what diagonals are. We learned about them in parallelograms. We learned some cool things like how the diagonals bisected each other in parallelograms. That will be true for rectangles. But now we get this even more powerful idea, and here it is. The diagonals of every rectangle are congruent. So here's rectangle ABCD. What I can conclude, because rectangle ABCD is a rectangle, is that AC is congruent to BD. This is pretty handy dandy. You may not see it now, but whenever you get to writing proofs regarding rectangles, this allows us to show some pretty cool things. In your homework, you're doing a 2-column proof that's going to use properties of rectangles. You've got to know about bisecting diagonals, all this sort of stuff. And this may or may not show up as one of your quote-unquote reasons in your proof. Okay? If you're still writing this down, keep writing it down. If you are done, you may move on. If you need more time, pause the video. If not, we are going to continue on. So my first example here is, suppose that you're walking in a rectangular park with the following diagram below. And when I say rectangular park, I mean rectangle PQRS, okay? That is the rectangle we're looking at. Yeah, it may not look like a perfect rectangle. Get my drift. PR is a diagonal and QS is a diagonal. They intersect at point T. And my goal here, and I hope you enjoy the drawings, you know, we got a dog that's not very well drawn, a chair that's not good, and a tree. So, oh no, there we go. That was close. So yeah, we have this great drawing by Mr. Bivens himself. Again, I'm not an artist, no need to critique me there. But our question is, let's suppose PS is 180 meters and PR is 200 meters. So, PS, and I'm going to use, what color are we going to use here? We'll use some gray, we'll use brown. PS, they tell me, is 180 meters. They also tell me that PR is 200 meters. And they say find QT, which is right here. Find this. Let's think about what properties of either parallelograms or rectangles do we know that can help us solve this problem. So I'll give you a moment, pause, try and figure it out on your own, and then I will reveal my solution. Okay, so here's what I know. I know that diagonals of rectangles bisect each other. So the two diagonals in this case are QS and PR. Because they bisect each other, I know that the resulting line segments are congruent. Furthermore, I know that both diagonals are congruent. So QS is actually congruent to PR. Well, if PR is 200 meters, I know that QS has to be also 200 meters. I also know that because diagonals bisect each other, this point T is actually the midpoint of the line segment. And so if I'm looking for QT, well, T is the midpoint of QS. That means that QT must be 100 meters. That was my logic. You could have even done a really cool triangle congruence proof here. You could have done a couple things, but yes, QT is going to be 100 meters based upon these two diagonals bisecting each other and that PR and QS are congruent through the properties of a rectangle. Fun little problem. Now we're quickly going to chat about how we show that a four-sided shape is a rectangle. So similar, excuse me for the backup, I'm a little stuffed up here. Remember back in 6-3 when I said, hey, let's look at this random four-sided shape and determine is it even a parallelogram or not in the first place. We are doing that similar thing here but with rectangles, and the main qualification that we're going to look for is if our diagonals are congruent. So, and this is kind of, you know, lingo math. So basically, if you are looking at any four-sided shape and you happen to notice that the diagonals of this shape are congruent, then you can conclude that the shape you are looking at is a rectangle. Again, this is similar to 6-3 when we were looking, is this shape a parallelogram or not? Okay, this is one of the concepts, kind of going backwards. So if you need a moment, write that down, pause the video. If not, we are going to move right on with my favorite example of the day. This is a dodgeball example. So suppose you are Mr. E, aka my boss, aka your principal. Put yourself in his shoes and you want to build a rectangular dodgeball field, but not just any dodgeball field, one that meets professional standard qualifications. I did some research and found out that dodgeball fields to play professional games on, there's a lot of really strict things about it. First of all, this field has to be a rectangle. Why? I don't know. Some dodgeball committee probably decided that. But our goal here is to going to explain why the field that I have drawn below qualifies as a rectangle. Here's a picture of the field. Again, it's not drawn to scale. This was a picture I found online, and then I just kind of traced it. I'm probably back over here. I would never get out in dodgeball. One of y'all got out, so that's kind of embarrassing. And, it looks like the team on the left is going to be the team on the right. We've got a couple dodgeballs sitting around. So, yeah, not a good day to be a dodgeball. But, again, we want to show, is this a true rectangle? Like, I'm looking at it. It looks kind of like one. I really don't know, okay? So, hopefully, we can use what we literally just talked about and determine if this is a rectangle or not. So, I'm going to give you some dimensions. Take a moment. See if you can figure out, is this a rectangle or is it not, okay? Here's the dimensions. Pause the video, and then whenever you're ready, press play, and I'll reveal the solution. Okay, it sounds like you clicked on pause, if you even paused it in the first place. And we're given some dimensions here of this shape that looks four-sided, looks like it could be a rectangle. They tell us that LM is 60 feet long, so I'll go ahead and write that down. They tell us that MN is 30 feet. They tell us that NO is 60 feet. And they tell us that OL is 30 feet. Okay, looking good. I know it's a parallelogram, at least. How do I know that? If you just talk to your computer, phenomenal work. I see that opposite sides are congruent. All of the opposite sides are congruent. So I can conclude we are at least looking at a parallelogram. But I know for this shape to be a rectangle, what has to be true? Yes, very good. The diagonals have to be congruent. And do they give us any information about the diagonals? Sure betcha. They say that LN, I'm going to draw that now, that whole thing is 67 feet. They also tell me that MO is 67 feet. And if you are a brainiac, like I think you all are, those are the same numbers. 67 is equal to 67. So both of our diagonals are the same, AKA they're congruent, AKA this is indeed a rectangle, and this is rectangle LMNO. We have just found that Mr. E, we actually can go build this professional dodgeball court. So Mr. E, we're going to need you to get on that soon. I'll have my geometry students send you a proposal momentarily. Continuing on. We got to throw some algebra in there. You took Algebra 1 before this class, so let's use it a little bit. Suppose, and I'm going to start using this fun little suppose sign. It means suppose. It's quicker to write. Suppose we have a quadrilateral PQRS with vertices. P is negative 5, 3. Q is 1, negative 1. R is negative 1, negative 4. And S is negative 7, 0. And again, our job, determine if this is a rectangle or not. And we're going to use the distance formula. Similar to what we did with parallelograms, we saw were the opposite side lengths congruent. And we can do the same thing with the parallelogram. So I've got, why did this just move? Oh, jeebers. So we're going to draw a picture first because, again, I don't know what's going on here to draw a picture. So here's a four-sided shape. Again, okay, let me not make it perfect like a rectangle. Here's a four-sided shape. I'm going to say P, Q, R, and S. And they tell me P is negative 5, 3. Q is 1, negative 1. And again, this is not drawn to scale. This is just for me to have a semi-clear picture about what I'm looking at. Okay. I know if this is a rectangle, it has to have what? Very good, whoever just, again, talked to their computer. It has to have congruent diagonals. So what if we use the distance formula and see if the distance from P to R is the same as the distance from S to Q? We have coordinates. We hopefully know a distance formula. We can actually find what this is going to be. So I'm not going to actually completely solve this. I'm going to semi-get there. So let's find PR. That's equal to the square root of, take our x values, which in this case we'll do negative 1 minus 5 squared. We'll add that to negative 4 minus 3 squared. When I do that, I get square root of negative 1 minus 5 is negative 6 squared is 36. Negative 4 minus 3 is a negative 7 plus 49. And 36 plus 49, let me pull out my handy-dandy calculator that I always keep on me. Boom, boom, boom. Just kidding, I use my computer. We should get the square root of 85. Okay, let's hold that thought. Square root of 85 for PR. And we'll drag this up. And so we just found that PR, again, is square root of 85. Is there units? No units. And we also need to see, is the other diagonal the same? Is QS or SQ congruent? So let's go ahead and do that now. QS is square root of negative 7 minus 1 squared plus 0 minus negative 1 squared. So I get square root negative 7 minus 1 is a negative 8. 8 squared, 64. Plus 0 minus negative 1, that's going to be a positive 1. 1 squared, square root 65. And lo and behold, this is indeed not a rectangle. I feel like I did something wrong because my answer key shows it is a rectangle. Times in math, we do certain problems wrong, and that is okay. But I'm showing that PR is indeed square root of 65. So let's go back and check our math on PR. QS is square root of 65. PR should also be that as well. So let's go see what I did wrong. Negative 5 minus a negative 1 should be a positive 4. So that first part should be a 16. And then the second part, that 3 minus, 16 plus 49 should also be square root of 65. So I did not do negative 5 minus negative 1. I just did negative 5 minus 1. That hurt me. And so negative 5 minus negative 1 is a negative 4, which would have give me the 16 in the first part. So that was kind of awkward. Mr. Bivens messed up the distance formula. That is okay. It happens. If I was not working as quick, I probably would have gone back and checked that anyway. So they are both square root of 65. So if both of my side lengths, aka not side lengths, my diagonals are both square root of 65, what can I conclude about this quadrilateral PQRS? Cash money, it is a rectangle. That is all, folks. Quick recap. Rectangles have 4 right angles. Their diagonals bisect each other and are congruent. And rectangles have all properties of parallelograms. Thank you all for tuning in. If you want some more practice, here's a quick practice page. I will leave this up momentarily. If you need the answers to this, I got them on the very next video slide thingy right here. And in case you cannot find the homework, here it is. This will be due, again, Monday the 14th of January. It's 12 questions, not too bad. Again, you're using what we talked about in the video. Thank y'all for watching. Mr. Bivens out.